In this screencast, we want to compare how the Gibbs free energy and the fugacity of a single component changes as we change the temperature. And the way we're going to do this is use water and calculate the Gibbs free energy from the steam tables. And we'll do this at two temperatures and the same pressure. And then we'll also calculate fugacity from Gibbs free energy values. Okay, so the Gibbs free energy is just defined as H minus Ts. And so then we can use the steam tables to look up H and S and calculate G. And we've done this in a separate screencast to show you these calculations, how the calculations are done. We can then calculate the fugacity by looking at differences, Gibbs free energy. So this is Gibbs free energy at the value you're interested in, Gibbs free energy for the same temperature but at conditions where the molecule is an ideal gas. And so RT log fugacity over pressure. And so this pressure corresponds to the pressure where we calculate this Gibbs free energy, because if it's an ideal gas, fugacity equals pressure for an ideal gas. And that's important. This low pressure, we can calculate this Gibbs free energy from the steam tables. Again, this is done in another screencast, so let's just look at the numbers. So let's first look at the Gibbs free energy at two temperatures and the same pressure. This is at 250 C, this is 350 degrees C, and what we see is that the Gibbs free energy decreases, and this is what we expect. We can relate the Gibbs free energy to other state variables as such, and then at constant pressure, this term is gone, and since S is greater than 0, as the temperature increases, the Gibbs free energy decreases. Indeed, that's what we observe. In contrast, if we look at fugacity, we look at the fugacity values. As we increase the temperature, the fugacity increases. Well, why is this? This is because as we increase the temperature, we approach closer to ideal gas conditions. In other words, at a given pressure, a molecule is more like an ideal gas at a higher temperature. If it were an ideal gas, since the pressure is equal to 2.5 megapascals, then the fugacity of ideal gas would also be equal to 2.5 megapascals. So we can see at 250, fugacity deviates more from an ideal gas than at 350. Thus, as we increase the temperature, the fugacity increases. Thus, we see that Gibbs free energy and fugacity have opposite temperature behaviors, because the fugacity is some indication of deviation from an ideal gas, whereas the Gibbs free energy is related to the entropy. The other thing to point out here is that the Gibbs free energy for a single component is the same as the chemical potential. So this says as we raise the temperature, the chemical potential decreases for a single component.